Good morning, sir.
Good morning, sir.
Name.
Good morning, sir.
Okay. Now, यूनिट 4 के जो बस थोड़ा सा बाकी है उसमें है पावर सीरीज सो पावर सीरीज का कन्वर्जेंस एंड द पावर सीरीज का इंटरवल और कन्वर्जेंस ये सब है. So what is power series? A series of the form a0 plus a1x plus a2x square, this type of series, an x to the power n and so on. This is power series. Power series in
हेलो.
x.
हेलो.
हाँ बोलिए.
हाँ.
खाना खा के खा लीजिए.
हेलो
जा रहे हैं मेरे का.
ठीक है. So this is a power series in x, where a, this a, that means ai, are independent of x. Independent of x. So this is power series. So in this series, un is equal to an x to the power n, and un plus 1 is equal to an plus 1 x to the power n plus 1. So here this ai may be positive or may be negative. Now limit D'Alembert ratio by D'Alembert ratio test. Limit n tending to infinity un plus 1 by un is equal to limit n tending to infinity an plus 1 x to the power n plus 1 by an x to the power n. That means this is x. Now take an plus 1 by an is equal to k. So this is a constant actually. So this will be k into x. Now, if by D'Alembert ratio test this is less than 1, then the series is convergent. The series is convergent. 1 minute. Okay. Now this series is convergent when mod of kx less than 1. That means the power series, okay, now mod of kx, that means mod of x is less than 1 by k. This means mod of k less than 1 by k means minus 1 by k less than x less than 1 by k. So the power series is convergent where the power series is convergent if this minus 1 by k less than x less than 1 by k. So actually the interval, this interval minus 1 by k less than x less than 1 by k is the interval for convergence. Interval for convergence of the power series. And outside this interval, outside of this interval, the series is divergent. The series is divergent. Example.
Sir, why you are taking mod, sir? In the almost that you mod.
Okay. First take an example, then explain the mod. Take the series x minus x square by 2. Okay, first discuss why mod. Actually जो D-Alembert रेशियो टेस्ट था उसमें जो सीरीज UN वो क्या था, वो था पॉजिटिव टर्म सीरीज, राइट?
Yes, sir.
So k is a number, actually a positive number, right? And for k less than 1 the series is convergent, and for k greater than 1 series is divergent. Okay, now here the ratio is k into x. This may be positive or negative. Okay, for that case actually we take convergence because we want the actual numerical number. Okay.
Okay, sir.
Now x cube by 3 minus x to the power 4 by, okay, this is 2 square, 3 square, 3 square, 4 square, and so on. Find the value of x. Find the value of x. For that the series, for which the series is convergent. So find UN is equal to x to the power n by n square minus 1 to the power n minus 1 or n plus 1. UN is equal to minus 1 to the power n, x to the power n plus 1, n plus 1 square. So UN plus 1 by UN is equal to, this will be n square minus of n square n plus 1 square into x. So if we take limit, this will be minus of 1 plus 1 by n square into x. So limit is 1 plus 0 into x, that is minus x. Okay. Now, since this is minus x, we calculate, we take the modulus value of x, just mod value. So when mod value less than x, the series is convergent. Okay. And when mod value greater than 1, the series is divergent. And when mod value equal to 1, that means when x equal to 1 and x equal to minus 1, we consider these two cases. Consider this case when x equal to 1 and x equal to minus 1. When x equal to 1, the series is 1 minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square. So this series is alternative series. Alternative series.
Absolute common.
And by Leibniz test, this is convergent, right?
Yes, sir.
And when x equal to minus 1, the series will be minus 1 by 2 square minus 1 by 3 square minus 1 by 4 square. This series, that means if we take minus common, so this is 1 by 2 square, 1 by 3 square, 1 by 4 square. So this is actually minus of which series it is?
P series.
P series. P series for P equal to 2. Now P series is convergent. That means minus of P series also convergent. So this is a convergent series. So the series is actually, so here for x for x less than 1, the series is convergent. Mod x less than 1, series is convergent, and mod x equal to 1, the series is convergent. So hence we can say the interval of convergence of this series is this: minus 1 lesser or equal to x lesser or equal to 1. Now exponential series is, this is a one time of power series, 1 plus x plus x square by factorial 2, x cube by factorial 3, factorial n, and so on. This is an exponential series. Exponential series. Okay. Now we look the convergence of the series. So here un is equal to x to the power n minus 1 by x to the power n minus 1 by factorial n minus 1, and un plus 1 is equal to x to the power n by factorial n. So limit n tending to infinity, un plus 1 by un is equal to n tending to infinity, this will be x to the power n by factorial n into n minus 1 factorial to n minus 1. So limit n tending to infinity, this will be x by only n. So as n tends to infinity, the limit is 0. 0 is less than 1. So by D'Alembert ratio test, by D'Alembert ratio test, we can say that the exponential series E series is convergent for all values of x, for all values of x. Next, we test the logarithm series. So log of 1 plus x is equal to x square by 2 plus minus x cube by 3 x to the power 4 by 4 minus 1 to the power 1 to 3 power n minus 1 x to the power n by n and so on. So we find the convergence interval, in which interval the series is convergent. So here un is equal to minus 1 to the power n minus 1 x to the power n by n, and un plus 1 is equal to minus 1 to the power n x to the power n plus 1 by n plus 1. So limit n tending to infinity un plus 1 by un, n tending to infinity minus 1 to the power x to the power n plus 1 by n plus 1 into n minus 1 to the power n minus 1 n x to the power n n. It means minus 1 into x into n plus 1. Now take the limit. So limit n tending to infinity n by n plus 1 minus of this this is equal to minus of limit n tending to infinity 1 by 1 plus 1 by n into x. So actual limit is 1 plus 0 into x, that is minus x. So this series is convergent when mod x less than 1. This series is convergent when mod x greater than 1. The series is divergent, and for mod x equal to 1, that means x equal to 1 and x equal to minus 1. When x equal to 1, the series is 1, 1 by 2, minus 1 by 3, 1 by 4, up to infinity. This series is divergent, na? Divergent or convergent?
Divergent.
Correct? No. This is top class.
Conditionally convergent.
This is convergent or divergent?
Convergent only, sir. Alternative but
Right.
conditionally convergent.
Yes. Conditionally convergent, because we take the 1 plus half 1 by 3, 1 by 4, then the series is divergent. So this is convergent series, and if we take minus 1 by 2, minus 1 by 3, minus 1 by 4, okay, and if we minus 1 common, so if we take minus 1 common, then 1 plus half 1 3 1 by 4, this. Now this series is divergent, right? So minus of this series also divergent, right? So the series is convergent where? The series is convergent when x less than or equal to 1, they have, right? So the series is convergent here. convergent. Okay. So actually, is screen visible?
Yes, sir.
Wait. So here is the procedure, total procedure. Procedure for testing a series for convergence. What is the procedure? That is, what is the algorithm? First, we find that the given series is a the series is a series with terms alternatively positive or negative. Alternatively positive or negative. That means is it a alternative series or not? Second, we test. Actually, second we check the series is a positive term series or not. A series of positive term exclude power series. And third, check is it a power series. Okay, so if it is a alternative series, then for one apply Leibniz test. If it is not a power series, it is a second case, a positive term series, then first you find un. Okay, and if possible, find limit n tending to infinity un. If limit n tending to infinity un not equal to 0, the series is divergent. And if n tending to infinity un equal to 0, then compare the series compare the series un with a power series, that is 1 by n to the power p, and apply comparison test. Comparison test. Now, if comparison test is not applicable, if comparison test is not applicable, then apply D'Alembert ratio test. Ratio test. If ratio test fails, then apply what? Rabbit test, right? If rabbit test fails, then apply
Gauss test.
Gauss test. If Gauss test fails, then apply
So when can we use Cauchy's test?
Cauchy's test also. Logarithm test. Logarithm test. If logarithm test fails, you can apply Cauchy's test also. Cauchy's test. And if the series is a power series, apply the ratio test. If it is a power series, then apply ratio test. If ratio test fails, if this test fails, follow the step for the second case. If fails, then follow test for the second case. So this is the procedure.
Sir, for the third case, if you're saying it fails, follows test for second case, that means after ratio test, in the second case, we are doing rabbit test, then that fails then. So we'll continue after that.
Yes.
वहाँ से चालू करेंगे.
Yes. Then consider the power series as a positive term series. Consider the power series as a positive term series.
Positive term series and applying test after the ratio
test.
test in the
Right.
positive series.
Yes. Okay. बस सीरीज का हो गया. नेक्स्ट है यूनिट 3 शुरू होगा. ठीक है. ओके ठीक है, चलो आज का यही तक.
Thank you, sir.
हाँ.
Thank you, sir.
Thank you, sir.